Phase 1. Building the perfect ovoid. Let us start by sketching an egg profile, also known as an ovoid. In a previous post, I created an egg by lofting two ellipses, but I consider that method a bit like cheating. Unfortunately, I did not have much time to study the material back then. Today, we will build a true ovoid, what chickens would call the perfect egg. Damn! I have already adjusted the canvas to convenient numerical values, so let us begin by creating the base of the egg. This is a circle with a diameter of 100 millimeters. Next, on the line that cuts the circle in half, we will create another circle with a radius equal to the diameter of the base circle. We will create a second one for symmetry. As we can see, these two circles are tangent to the base one and are already forming the sharp end of the egg we are looking for. From the center of either large circle, let us draw a guideline to the very top point of the base circle. This will give us a convenient snap point. From this same point, through the previous point, we will draw a line ending at the boundary of the large circle. Now, draw a circle from the top point of the base circle to the previously found point, with a radius equal to the distance between them. We have obtained our second tangent point. Now we can clean up the sketch by removing the construction lines. Let us keep half of the profile. As you can see, the profile matches the reference quite well. Let us apply the Revolve tool to get our surface. Phase 2. Modeling the dragon scales. Let us create the dragon scales. On both sides of the center line, I will create two vertical lines that will limit the width of a single scale. I will make it slightly wider than the visible part, keeping in mind that it will be overlapped by adjacent scales. I am creating the scale profile at the level of the base circle center. Let us transfer the scale height from this fragment. For convenience, let us mirror the boundary downwards, since we do not know where its true base is. Using the arc tool, we will create the sides of the scale. Done. Let us clean up the excess. Duplicate it and name the base surface. Hide it, and cut the scale profile out of its duplicate. We need to tilt the front surface of the scale relative to its horizontal baseline, creating a flared-out effect. You can delete this polygon. Its influence is insignificant, but it can greatly complicate the geometry of a single element. I will get rid of half of this cutout profile to safely tilt the upper part. Let us subtract the base body from the scale body, making sure to keep it. We can slightly simplify the geometry of the inner part and push it in a bit, to hide or avoid potential artifacts on the sharp edge during filleting. Phase 3. Patterning and detailing. Let us rotate the scale element closer to the original egg profile line. We will pattern it along this line, taking the normal into account, symmetrically in both directions. On the reference, we have 7 fragments. Let us pull up the upper boundary. Since our scales are in a staggered pattern, to avoid complex positioning work, let us also create these fragments for the spaces between rows in one pass by multiplying the number of fragments by 2. We can see that because the top part of the egg is longer than the bottom, the scales wrap awkwardly at the bottom. We will add 2 more scale fragments to disable them on the bottom side, breaking the symmetrical distribution. If you count the number of scale fragments, you can see that in each row of the segment between the vertical dividing threads, there are 2, either 2 whole ones, or 1 whole one in the center and 2 halves on the sides. Since there are 6 sections, there are 12 scale fragments in a row. Let us offset every second element by 15 degrees relative to the vertical axis. Now we have 1 cycle. Let us pattern it 12 times around the vertical axis. We will create the vertical thread of the sector by creating a new sketch and projecting the base profile with an offset. This allows us to fix defects where the thread sinks into the scale geometry. Conclusion. I did not show the process of creating the remaining primitive elements. You can practice that on your own. Also, by making a component out of the very first scale element, you can apply changes to every element by editing just one. Now, if you want, you can combine the dragon egg into a single object, depending on your goals. In this model, I also used another interesting exotic trick, leaving an Easter egg for the attentive viewer, so to speak, and planting a delayed action byte. Try to repeat this. You will succeed.